Hi, welcome to R&AC Academy. My name is Ram Prasad. Let me give a small brief about me. I did my masters in R&AC and then I worked for 25 years with various organizations involving in product development and technology innovation functions. I had 5 patents filed on my name. Out of my passion, I transitioned into teaching. Presently, I am into coaching GATE and IES aspirants on R&AC subject. I also conduct workshop on R&AC systems, faculty development programs, etc. for the engineering colleges. Recently, I conducted webinars for the members of ISHRE and ASHRE. Based on the response I received for the lectures on refrigeration systems, I am presenting here with a series of lectures on psychrometry, again for the benefit of the students and the professionals. I believe these lectures will also add a great value to all of you. This is the 6th lecture in the series of lectures on psychrometry. In this lecture, I will discuss the summer air conditioning system with 100% recirculation air. Let us start with the system that has zero bypass factor. We all know that for summer, the moisture must be cooled and dehumidified. By the time we reach this stage in air conditioning system design, we must have completed the heat load calculations. Hence, we have the RSH and RLH values available with us. You have a room that is required to be maintained at state I against the heat gains, namely RSH and RLH by the room. Let us plot the state point I on the psychrometric chart. The air that comes out of the room at state I will be recirculated. Hence, the state of the air entering into the coil will also be at state I. As the moisture must be cooled and dehumidified, the coil surface must be maintained at coil ADP. As the bypass factor is 0, the state of the air at the coil exit will be at C. And also, the state of the air supplied into the room will also be at state C. A fan is used to circulate the air within the system. Before we get into the calculations part, let me first make you familiar with certain nomenclature. The process line IC is called the condition line for the coil. What does it mean? It means that the moisture is entering the cooling coil at state I, getting cooled and dehumidified in the coil, and then exiting the cooling coil at state C. Similarly, the process line CI is called the condition line for the room. Again, what does it mean? It means that the moisture is entering the room at state C, gets heated and humidified by picking up RSH and RLH from the room, and then exits the room at state I. Please note that the load on the coil and the load on the room are same in this case. What is the significance of this? We will see it in the next slide. Now, let us look at what does the state point C and state point I represent. The state point C represents the condition of the coil surface, the condition of air at coil exit, and the condition of the air supplied into the room. Similarly, the state point I represent the condition at which the room has to be maintained, the condition of recirculation air, and finally the condition of the air at coil entry. This understanding helps us gain good clarity on calculations. Let me now take you to the calculations part. From the heat load calculations, we have the RSH and RLH, and their sum is equal to RTH. What is the significance of RTH here? RTH is the minimum cooling capacity required from the air conditioning system. But If we select the refrigeration system with RTH value alone, then that selection could be erroneous. This is because a refrigeration system will give different cooling capacities at different evaporating temperatures. In the sense, as the evaporating temperature increases, the cooling capacity produced by the refrigeration system increases and vice versa. Therefore, we should know at what evaporating temperature we want the air conditioning system should give us a minimum cooling capacity of RTH. In other words, we should find the coil ADP. We can compute RSHF using RSH and RTH. Then we can find the coil ADP on trial and error basis using this expression. We know Ti and Wi corresponding to the state point I. Assume a T value and collect the corresponding W value from the psychrometric chart. Substitute the T and W values in this expression against TADP and WADP respectively and see if the LHS value and the RHS value are becoming equal. If not, iterate by changing the T value accordingly. When the LHS value becomes equal to the RHS value, then that T is called the coil ADP. As discussed in the previous lecture, the coil ADP is the optimum state at which the coil surface must be maintained for the given sensible heat factor and entry air state. The line joining I and C is called the RSHF line. The RSHF line intersects the saturation curve at room ADP. But we are calling the same as coil ADP. Then where do we get the room ADP located on the psychrometric chart? Here is the answer. Whenever the load on the coil is equal to the load on the room, then the coil ADP is equal to room ADP. Therefore, the location of room ADP and coil ADP will be same in this case. Does it mean that the coil ADP and the room ADP are same always? It need not be. It is same in this case because the heat load on the coil and on the room are same. Having known the RTH and coil ADP, we can now select the refrigeration system that has the minimum cooling capacity of RTH while operating at coil ADP. In addition to this, we also need to give the specification for fan selection. This comes from the computation of CMM using this expression. With this, the design calculations for summer air conditioning system with 100% recirculation air and with the zero bypass factor are done. We now have the specifications for selecting the suitable equipment available with us. The next step from here would be to execute the design. Let us now look at the case number 2, that is summer air conditioning system with 100% recirculation air but with a bypass factor of X. In this case also, the RSH, RLH, TI, WI and HI will be remaining same as the previous case, but the state of the air at the coil exit will change because of the bypassed air. Let us look at that. We have a room that is required to be maintained at state I against the RSH and RLH. The state of the recirculation air and also at the coil entry will remain at I. Plot the state point I on the psychrometric chart. We all know that for summer the moist air must be cooled and dehumidified. Hence, the coil surface must be maintained at coil ADP. If the bypass factor of the cooling coil is 0, then the state of the air at coil exit and also at room entry would have been at C. But in this case, some air is bypassing the coil and hence the state of the air at coil exit will not be at C. But it will definitely be on the line joining I and C. We can have its exact location using the coil bypass factor supplied by the coil manufacturer. Therefore, S is the state of the air coming out of the coil and also supplied into the room. Before we get into the calculations part, let us look at certain nomenclature. The process line IS is called the condition line for the coil and the process line SI is called the condition line for the room. Please note that in this case also the load on the coil and the load on the room are same. Now let us look at what does the state points S, C and I represent in this case. The state point S represents the condition of air at coil exit and the condition of air supplied into the room. The state point C in this case represents the condition of the coil surface and also the condition of air at coil exit which contacted the coil. The state point I represents here also the condition at which the room has to be maintained, the condition of the recirculation air and the condition of air at coil entry. Additionally, here the state point I also represents the condition of air that bypass the coil and entering into the room. Let me put it pictorially. We can visualize the situation as two independent air streams such that one stream at state I is passing through the coil, coming in contact with it and attaining state C at coil exit. The other stream at state I is bypassing the coil altogether. Hence, at room entry, we have one stream of air entering at state point C and the other stream is entering at state I only. But the important consequence of this phenomena is that only the air stream at state C will actually be contributing towards the cooling of the room. The air stream at state I will not contribute towards the cooling of the room. Then, will the room be gaining additional heat due to this? The answer is no. It is because both the room air and the bypassed recirculation air are at state I and hence no additional load on the room due to the bypassed air into the room. Let us now get into the design calculations part. The RSH, RLH and state I will remain same. Hence, the RSHF and coil ADP also remain unchanged irrespective of bypass factor is equal to 0 or bypass factor is equal to X. Hence, the refrigeration system that was selected in the previous case can be used for this case also. No need to change it. Then, what will change in this case? Let us look at that. In the expression for RSH, the delta T value will be decreasing, but the RSH value remains unchanged. Hence, to compensate that, the CMM value must increase. Therefore, the CMM specification for fan selection will be done using this expression, and it can be rearranged like this also. The CMM value in this case will be higher than that in the previous case. This can be summarized as, for a given cooling coil and room inside conditions, the CMM has to be increased with the bypass factor. But when the airflow rate is increased, the exit air temperature increases. And that is what is happening here. TS is greater than the coil ADP. With this, the design calculations for summer air conditioning system with 100% recirculation air and with the bypass factor is equal to X are done. With this lecture is completed. In case you have any questions, doubts, etc., please feel free to write to me. The next topic is summer air conditioning system with ventilation air and with zero bypass factor. See you then. Thank you very much.